Hello guys, how are you? Welcome to Cosmic Essence Education. My name is Maitray and in this video we'll be looking at continuous compound interest. So let's get started. Okay, so before looking at the continuous compound interest, let's start with what compound interest is and what is the formula for compound interest. Now, compound interest is different from simple interest in a way that simple interest gives us interest on the principal only, whereas in compound interest we get interest paid to us or given by us on the interest as well. So interest on interest is given in compound interest. Okay, let's take an example to understand. Say I deposit 100 rupees in the bank. This is my principal amount, and say the bank gives me 10% simple interest. So after 1 year, in simple interest, after 1 year I will be having 100 plus 10% of 100, that is 100 plus 10, 110 rupees in the account. And in the second year, again 10% on the principal amount will be given to me, that is 10 rupees. So in the second year the total amount in the bank account will be 120 rupees. Now in the case of compound interest, the interest, say it is again 10% but compounded, it is a compound interest. In the first year the interest will be paid on 100 rupees, so that is 10 rupees. So the total amount after 1 year will be 110. But for the second year, now the interest will be paid on this amount, on the current amount in my bank. So this time the interest will be paid on this amount. 10% of this is 11 rupees. That means the amount I will have in my bank after 2 years will be 110 plus 11, which is equal to 121. So in the compound interest, the interest is being paid on the interest I had initially got as well. Okay, so now after getting the difference between simple interest and compound interest, let's get a formula for compound interest. So a few terms first. U naught is the initial amount, also known as the principal amount. I is the interest rate paid every compound period, or per compound period rather. And n, small n, gives us the number of compounding periods. Now let's see. So the initial amount we have is U naught. After one period, the amount we will have will be U naught plus I U naught, I percent of U naught. So this is equal to U naught into 1 plus I. After the second compounding period, this will be equal to U1 plus I U1. So the interest will be paid on U1 this time. So this is equal to U1 into 1 plus I, which is equal to U naught into 1 plus I whole to the power 2. After the third compounding period, this will be equal to U2 plus I U2, which is equal to U2 into 1 plus I, which is equal to U naught into 1 plus I whole to the power 3. So looking at this pattern, we can see that the interest or the amount we will have after n periods will be equal to U naught into 1 plus I whole to the power n. And this gives us the formula for compound interest. This actually gives us the final amount that we have after n compounding periods when the interest rate per compounding period is I, and n and u naught is the initial amount. Okay, now in most cases the interest will be given us in terms of per year. So let's take R as the interest rate per year. Let T be the number of years and let capital N be equal to the number of times interest is paid in a year. Then I, which is our interest rate per compounding period, will be equal to R upon N. For example, suppose R is equal to 12% per year. PA means per annum, which is same as per year. Then if capital N is equal to 2, this means that if the interest is paid every 6 months, so if interest is paid every 6 months, the interest is paid 2 times in a year, so capital N becomes 2. In this case, I will be equal to 12 by 2, which is equal to 6%. Now suppose the interest is being paid monthly. In that case, capital N will be equal to 12 and interest rate per compounding period will be 12 by 12, which is 1%. Also, small n will be equal to capital N into T. That means the number of compounding periods will be equal to number of times interest is paid per year into number of years. For example, if n is equal to 2, then small n is equal to 2t. So in a year there will be number of compounding periods will be 2. In 2 years number of compounding periods will be 4, and so on. If n is equal to 4, then small n will be equal to 4t. So now the formula becomes un is equal to u naught into 1 plus r upon capital N whole to the power capital N into t. This is the formula for compound interest when R is the interest rate per year, capital N is the number of times interest is being paid in a year, and this gives us the number of compounding periods. Okay, so let's start with continuous compound interest. So that for that we'll have to make the compounding periods become smaller and smaller and smaller. So let's start with an example and see what happens. So u naught is equal to say $1,000 and the interest rate per year is equal to 12%. Then if n is equal to 1, that means interest is compounded yearly, un is equal to u naught into 1000 into 1 plus 12 upon 100, 12% into 1 as capital N is 1 to the power capital N into t, so only t. If interest is compounded every 6 months, then capital N is equal to 2, so un is equal to 1000 into 1 plus 12 upon 100 into 2 whole to the power 2t. If interest is compounded monthly, then capital N is equal to 12 un is equal to 1000, 1 plus 12 upon 100 into 12 whole to the power 12t. If interest is compounded every minute, if it is compounded every minute, then capital N will be equal to 12 into 20, it will be 365 into 24 into 60. So UN will be equal to 1000 into 1 plus 12 upon 100 into 365 into 24 into 60 whole to the power 365 into 24 into 60 into t. Now, what do we mean by continuous compound interest? Continuous compound interest means that the interest is being paid instantaneously. It is being paid every moment. So, every moment we are getting interest, then in the next moment we are getting interest on interest, and so on, it keeps on going. So, it is being paid instantaneously. If it is being paid instantaneously, it would mean that the number of compounding periods or number of times interest is being paid tends towards infinity. So, as we see that the formula is un is equal to u naught into 1 plus r upon n whole to the power n into t. Let a be equal to capital N upon r, then un is equal to u naught into 1 plus 1 upon a whole to the power, capital N can be written as ar, so art. This can be written as u naught into 1 plus 1 upon a whole to the power a whole to the power rt. Now, in the case of continuous compound interest, the interest being paid is every moment. That means capital N is tending towards infinity. Now, in this case, we have to take limits, we have to apply limits here, as n will tend to infinity, a will also tend to infinity. Now, in limits, we have that limit a tends to infinity, 1 plus 1 upon a whole to the power a is equal to e, and e is approximately equal to 2.718. And because of this, we see that we have 1 plus 1 upon a whole to the power a here. So this will be replaced by e, and we get un is equal to u naught into e to the power rt as the formula for continuous compound interest. Okay guys, so we looked at continuous compound interest in this video. I hope you liked the video. If you did, hit the like button and subscribe to our channel.